For our second gas tank, we're going to do things a little bit differently. One change is we're going to be using aluminum. The chief advantage of using aluminum for a motorcycle gas tank is it's easier to fabricate. Steel is a very tough material, difficult to form with hand tools. Aluminum is a very soft, malleable material. It's a much more friendly metal to shape. Most of the motorcycle gas tanks I've made have been made from aluminum for this reason. Some people find aluminum a more difficult material to weld. I'm going to demonstrate a couple of different techniques for welding aluminum, and with practice, you can become quite proficient in welding aluminum. Another issue is that aluminum tanks in particular have to be mounted in a very special manner, otherwise the mounts can crack over time. V-twin engines have vibration that's inherent to their operation. When the engine is mounted rigidly to the frame, as it is on this motorcycle, the vibration goes into the frame, and anything attached rigidly to the frame vibrates, which over time can cause stress cracks. So we'll look at how to properly mount an aluminum gas tank. Another thing that's different about this tank is I want to have a more curvaceous shape, something that's curved on all sides. So let's start going through the design process of how we create a tank of that shape. So we have a piece of chipboard attached to the chassis, and I'm just going to start sketching in some lines here of a shape that I think will be pleasing. We need to have enough clearance so that as the fork turns, we'll have clearance. We don't want the fork or handlebars to crash into the tank. I want a nice low crown curvature for the top of the tank. You can see that I've sketched in a line that represents the top of the tunnel that will be going through the tank. We want to bring the tank back pretty close to where the seat will be. Obviously, we don't want a gap between the tank and the seat. And I want to stay pretty close to the top of the cylinder head. I don't want a huge gap in that location. And we'll start arching this down now. We'll give this tank sort of a kidney bean shape. And we want a nice big radius in the front. So that's kind of a rough sketch, but I think that's more or less the shape I want to have for this tank. So what's next is I'll take this off the frame and start to trim this pattern. And of course, if we don't get the first pattern right, we can make a second pattern or a third or a fourth pattern, which I often do. Paper is fast and cheap. Aluminum is slower and more expensive. And for the rear portion, I'm going to use a little disc so that I get a very nice constant radius on the rear edge. And now we'll trim that. Okay, our pattern is cut. We'll put this back on the frame. And when it's in place, I'll be able to stand back and really judge whether I do or don't like this shape. Obviously, if I don't like it, if it's too large, I can trim areas off. And if it's cut too short, it's easiest just to make a new pattern. So let's stand back and take a look. And I think I do like that shape. It looks good from here. So now that we have the pattern cut out, we're ready to transfer this pattern to a piece of aluminum and cut the piece out that we'll be forming. I want to talk a little bit about the kind of aluminum we're using. This alloy is called 3003H14. The 3003 part means it's very nearly pure aluminum, but it's had a trace amount of manganese added to it. The addition of manganese makes the metal a little bit stronger, and it makes it slightly easier to weld. The H14 part of the designation means it's in the half-hard condition from the mill. And the thickness of this material is 80 thousandths. And this is a pretty good thickness to use for a motorcycle gas tank of this type. Some of the old English motorcycles use 60 thousandths aluminum for the gas tanks, and as long as they're very, very well mounted with a rubber cushion, that can work pretty well. But on motorcycles with V-twin engines that have a lot of vibration, especially with rigidly mounted engines, it's a lot better to use a thicker material. So that's why I've gone to 80 thousandths material. So we'll put the pattern on top of the metal, and we'll use a scriber to trace around the edge. And now we'll use the Beverly shear to trim this part to size. So on the final pass, we're trimming off about a 1/4 inch of material, and I'm being very careful to follow the scribed line as closely as I can. Okay, we've completed the cutting. The very next thing you want to do is to deburr the part, because cutting with a shear like this leaves a razor sharp edge that could easily cut your hands. You'll notice I'm pulling on the file. A lot of times when working on sheet metal that can easily vibrate, the file will chatter less if you pull it than if you try to push it. We'll flip it over and deburr the other side. Okay, our part is deburred. When I buy this material, I specify that one side of it be covered with a PVC plastic. And this goes a long way toward preserving the finish of the material. Aluminum is very soft and scratches easily. But we're going to be heating this piece of aluminum to anneal it or soften it. So I need to remove the plastic sheet to prevent it from burning during the annealing operation. Every alloy of aluminum has its own temperature that causes it to soften. With this material, it's about 800 degrees. Okay, let's do a demonstration of the annealing process. I'm using a rosebud tip, a multi-orifice tip. I'm going to turn on a lot of acetylene and light the flame. Now with this pure acetylene flame, I'll put a coating of soot on a piece of metal. Now I'll add oxygen so that we have a neutral flame, and we'll start heating the piece of metal until the soot burns off. So the soot film will burn off at just about 800 degrees, but it's very important that you don't overheat the metal, because we're just about at the point where it starts to melt. So be very certain not to overheat the metal. So let's get this molten piece out of the way. We'll get the gas tank half on the table. Spacing it up off the table helps keep the table from sucking heat out of the metal. And we'll put a soot coating on this piece of material. And then we'll heat the metal until the soot film burns off. And that's all there is to annealing aluminum. You can allow it just to cool slowly in the air, that's fine. It's also fine to quench it with water. You won't harm the properties of this alloy of aluminum by rapid quenching. So now we're ready to start the shaping of the motorcycle tank side. Now on the first tank we made, we worked against a buck. And a buck is very useful because it provides a template that you can use to shape your pieces of metal to. This is a buck that we made out of MDF. This is a buck made of flimsy material. It's just 1/4-inch plywood, but it's still enough of a representation of the shape that it allowed me to make a motorcycle gas tank. The tank that we're making now is going to be made without the use of a buck. Probably if you're doing a gas tank for the first time, you'd find it very useful to make a buck. But once you've learned the ropes of the process, you actually can do a fairly good job oftentimes without taking the time to make a buck. So let's get on to the forming operation. We'll be working with a mallet and a sandbag. And basically we just place the metal on top of the bag and work into the bag with the mallet until we get a shape like what we want. So there's the result of our first round of hammering. You'll see that the part has taken on quite a cup shape, much more so than we want from front to back. So I'll use my elbows to help push the ends of the tank back where we want them. And now we can gauge how much doming we've achieved. Very slight, so we'll continue with the mallet and bag work until we have as much doming as we want. Okay, so our shape is very lumpy and it's taken on more curl than we want, so we'll correct the shape one more time. I'll press out with my elbows. And now we can gauge how much curve we have, how much crown we have. And we're getting close to what I want, but we'll use the mallet and sandbag one more time to give it a little additional dish. Correct the curvature from front to back. And I think you can see now we have a nice amount of doming on this tank half. That's about as deep as I want to go. So the next step will focus on smoothing this rather lumpy surface we've created. And the first step in doing that is to put a wooden block on my sandbag. Now when you're working into the bag, the harder you hit, the deeper the metal goes, and the bigger the bumps are that you get. When you work against a wood block, the metal only goes down until it hits the block and it can't go farther. So this is how we start smoothing the metal out. Okay, so I think you can see the gas tank half is a bit smoother at this point. I'm going to correct that curl from front to back just a little bit more. And now I want to test the flatness of this by trying it on the table. I'll curl this side a little bit more. Okay, and now we'll start smoothing this lumpy surface. Very convenient way to do that is by balancing a dolly on a sandbag and then working against the dolly with a slap hammer. Okay, that's about as much smoothing as I'm going to do with the slap hammer. First of all, the advantage of using the slap hammer is that it has a larger and lower crown face than a traditional body hammer. So it speeds the smoothing operation. And I think you can see that on this front quarter of the tank, we've done a fairly decent job of smoothing that metal out in just a couple of minutes' time. But for the rest of this tank, I'm going to use the English wheel because it's a good deal faster, and it actually, as you will see, leaves a smoother surface. Now, English wheels come in different flavors. We'll be using the small benchtop model on this tank half, and perhaps we'll use the full-size machine on the other half, so you can compare the operation of the two machines. So we spin the top wheel to help draw the metal into the machine, and then you simply work the metal back and forth, which smooths out the lumps and bumps. It's the steering on this machine that people have trouble mastering. The steering is done at the end of each stroke, and it's done by just a very small turning motion at the end of each stroke. I'm exaggerating that now so you can understand the principle. And once you get up to speed, it's done very quickly, and it's almost imperceptible to someone watching the operation. Okay, so there's our first pass at smoothing. It's certainly not perfect, but on the other hand, it is a lot smoother than it was when we started. So let's repeat that a couple of times. This set of tracks is at a slight angle in relation to the first set of tracks. I find that by changing my angle slightly each time, it helps me to smooth out the surface. And of course, you want to be very careful not to get your fingers pinched between the wheels. Very easy to do if you're not careful. So I think you can see now that with the second pass, we have a good deal more smoothness in the panel. And now we'll go back in for a third pass. Remember how bumpy the metal was when we went through the machine the first time? We've smoothed it out enough now that it's not bumping very much at all. Okay, I'll pull this out so you can take another look. So I think you can see the smoothness we have on this portion exceeds the smoothness we had on the portion done with the hammer and dolly. And I'm going to wheel over this entire piece now. I'm wheeling up to the edge, but I've not yet gone over the edge. We'll be treating the edge of this panel with a slap hammer and post dolly to put a little curl on that, so I don't need to wheel the edge of this panel. In fact, if you can, it's a good idea to avoid wheeling right on the edge of a piece of metal, because you run the risk of stretching the edge out of shape. So there's our panel, nicely smoothed out. So the shaping on this half of the tank is coming along nicely. It's fairly smooth and uniform in the middle. The corrections I'm going to start making will be on the edge of the tank half, and in particular the front edge and the rear edge. They both need to have more curl to them. And the most convenient way to curl down the edge of something that's rounded like this is to shrink it. The more you shrink it, the more it will pull down. So I've set up a mechanical shrinker on the edge of my bench, and we'll use that tool to shrink this edge and draw it down. This annealed aluminum is really a dream to work with. Very, very soft and malleable. We can do the same thing with steel, but it's just a lot slower, and it takes a lot more energy to make it move. Okay, I think we have about as much curl on the front edge as we want. So I'm going to hit the rear edge just a couple of times to help draw it down. Okay, and I think we've done what we need to do on the shrinker. So what's next is I'm going to start working with the post dolly and slap hammer to make the curl around the edge of this part much more uniform. So I'll put on my earmuffs for this. So the next step is to form the opposite side, the side that matches this, and that's always a challenge. On the first side, anything goes, whatever shape we like is what we get. And on the second side, of course, you need to make something that pretty accurately matches what we did on the first side. So I've gone ahead and done the rough forming on the second tank half, and I've just tried to match the contour we had in the first piece, both front to back and right to left. And we're reasonably close. So what's next is I'm going to use a different English wheel to do the smoothing on this part. So this time we'll be using the full-size machine. And the advantage of this machine is not just that it's larger, it's also smoother and faster. And the reasons that it's faster are not quite apparent. It's difficult to see, but the wheels for this machine actually have flat spots on them. The wheels for the benchtop machine are spherical. They have no flat spot whatsoever. So with the lowest crown wheel, the flat spot is a full 1 inch wide. So the analogy I like to use is it's like mowing a lawn with a wider lawnmower. It simply covers more area faster and leaves a smoother surface. So there's a set of 6 wheels that comes with this machine, and you choose the one that most closely matches the contour you're working on. If I was to wheel from front to back, I would be forced to use a wheel with lots and lots of curvature. Otherwise, only the edges of the wheel would touch. But if I wheel in the other direction, from side to side, I can use a much lower crown wheel, such as this one that's in the machine now. And the lower the crown of the wheel, the smoother the parts will come off the machine. So let's go ahead and put this into place. And we'll start wheeling this machine from left to right. A little bit bumpy to start with because of the large undulations left by the mallet and sandbag, but we'll get it smoothed up pretty quickly. So that's the result of our first pass on the machine. Some of the largest bunts have been taken out, but it's still a pretty wavy surface. So we'll continue with the smoothing. I'm actually going to decrease the space between the wheels a little bit. Bring the wheels closer together so they exert just a little more pressure on the metal. And you can both see and hear that it's much less bumpy this time, because we've simply smoothed the metal out. We've lowered the high spots and raised the low spots. Okay, we'll take a look at that. So it's quite a bit smoother at this point. And we'll continue the smoothing process toward the front of this part. Getting a little closer to the edges. Okay, I'll do a little wheeling right on the nose of this now. Okay, so the part is fairly well smoothed from this point back. And the reason I haven't done the extreme tip of this is because this wheel, this low crown wheel, doesn't fit that shape at all. I need a wheel with more crown to it. So we'll switch to another wheel. And now we can smooth the nose of the part. This part is fairly smooth at this point. Now, of course, our challenge is to make both sides match. So let's move this back to the table and we'll compare the shape of both parts. I don't expect them to be perfect, but we'll just go through the steps of adjusting the differences. So the biggest difference I see now is the space between the table and this portion of the tank. And what I can see is that if I simply twist the tank, kind of like a propeller, that will improve that fit quite a bit. So you can see this height is much closer between the two parts now. I'll just press this down a little bit, de-arch it. And again, I'm looking at the gap between the table and this edge, and they're really quite close at this point. The curvature in the front is matching quite nicely. Let's switch the parts right to left. And now I'm looking at the gap between the table and this edge. They're very close. I'm going to bend this part just a little bit, pressing out with my thumbs to improve the fit at that point. And that's looking quite nice. I can compare the parts in this manner to see that the curvature from front to back is fairly uniform. Turn the parts around like this and rock them together. Just gauging the contours, I want to get them as close as I can by eye. And I'd say the curvature on these parts are really very close at this point. So the last step is I'm going to start working on the post dolly again with the slap hammer, and I'll put the last little curl on the edge of this second part. So both halves are shaped now, and they match pretty well. And this is the part of the job that used to drive me nuts, getting both parts aligned and held in space some way so I could make a pattern for the top piece that will join them. I tried all different kinds of ways to hold them in place, and nothing seemed to work very well until one day it dawned on me I could shear little strips of metal and clamp the side pieces to those pieces of metal. And it holds them in place well enough that we can at least make a pattern for the part that joins them. So I've made a few witness marks on this panel. There's a mark showing me where the front edge is going to be of the top piece that we're patterning next. There's a mark that shows me where the rear edge will be. And turning the tank upside down now, I've made another mark in this spot, and let me show you what that spot represents. I'm using a square, and I found the place where the square touches both top and bottom on both the right side and the left side. And this enables me to be fairly sure that the sides of my tank are in proper alignment. Otherwise, it would be simply guesswork. And of course, we're making a tank freehand. We're making it without a buck, so there is some guesswork involved. But we want to minimize that as much as we can. So I'll be making the pattern for the top of the tank from chipboard. And I've cut a little tab on the end of this. And that's simply so I can slip it into place and have a place to clamp it in the rear of the tank. I'll just be using a spring clamp for that. Then we'll pull this up tight and put a second spring clamp in front. Adjust it so there's no gap anywhere, so it's a tight fit against both the right and left side of the tank. And now we're ready to mark our pattern. And I'll just use a pencil for this. Mark all the way along the left side. And then all the way along the right side. And now we have the pattern for the top of our tank. Before we unclamp this though, I want to mark lines on my pattern that match these witness marks I put on the tank halves. Okay, and now we can pull this apart and trim our pattern to size. So here's the pattern we've trimmed out. After I had the pattern trimmed, I went one step further. I drew a center line through the pattern and folded it over so I could test the contour of one side against the other. And actually I found there were some differences. So I retrimmed the second side to match the contour of the first side. This will ensure that our tank is more symmetrical. Working without a buck as we are, it's always a challenge to make your tank come out symmetrical, and it's actually better to make the center part so both sides match, and then I'll slightly reshape one of the sides to match the center. So the next step is I'm going to put our pattern on the piece of metal we'll be using. I'll weight it down, and using a felt tip marker, I'll trace around the edge. Before I take the pattern off, I'll carefully mark where our little witness marks are, so I'll know how this piece aligns to the gas tank sides. So here's our piece of metal after being trimmed, and we're ready to anneal it now to soften it to make it easier to work. So I'll space it up off the table, we'll dust it with carbon, and then we'll heat it until that carbon film burns off. Okay, our part is fully annealed. We'll allow it to cool now, and then we'll get on with the forming operations. So now that our part is annealed, the next step is to put it into the rough shape that matches the tank. So I'll just bend it against the table, and we'll start at the front and work toward the back. Just bending slowly by hand, and I'm using my little witness marks to assess how this fits against the tank sides. We don't have to have a super accurate fit at this point. I just want to put it roughly into shape. A little more curl in the back. Okay, that's close enough for now, and then the next step is that we'll start doming this using the mallet and sandbag. So I'll put my hearing protection on, and I'll be starting the doming near the front of the tank, and I'll just work in sort of a spiral to come out closer to the ends. You'll see it's curling a lot from front to back, so I have to correct that from time to time. I'll give it a little more doming still in the center. Okay, we'll correct the shape again. Try it back on the tank. Okay, the doming in the back is just about all that we need. I do want more doming in this area and a little more near the front. So we'll go back to the bag for that. A little bit more near the front. Okay, we'll try this on the tank sides again. Okay, now I realize this looks very lumpy and out of shape, but what I'm looking at this point is the all-over contour of the part. I know that I can straighten out the bumps with no real problem. So let's get on to that phase of the operation next. We'll use the full-size English wheel to smooth this part. I'm choosing a wheel that has a contour that matches the shape of this part from front to back. You might notice that this is a flatter contour than will fit side to side. We can only wheel right to left on this part, but the result will be a smoother part. So we'll put the wheel in the machine, put the part between the wheels, and start the smoothing operation. I'm using rather light pressure, and I'm going across the part at just about a 45-degree angle. And it's sounding pretty bumpy and clattery. That will smooth out rather quickly. So I'm going the other direction now. And I think you can see the part is starting to smooth up rather nicely. So after completing one pass at 45 degrees, I'll take the part out, go across the part at the opposite diagonal angle. And now you can see the part really starting to smooth out. Even after just about 1 minute of wheeling, the major bumps have been taken out of the area that I'm wheeling over. Okay, now I'll wheel across the part straight. And this is giving us a very nice dome. So my tracks are just about touching. Each track is about a ½ inch wide, and I'm moving the part slowly from side to side so the tracks just about touch. And we're going to try this against the tank halves now to see how the contours match. Looks like I have a little bit more doming in the part from front to back than what I need. So I'll put it on the bench, straighten that out. And now we can really take a look at the contour. And what I'm looking at is how this contour matches the tank itself. And it's actually pretty nice. I'll have to do a little work on the edge of this part to make it curl over to match the tank side. But the contour in the middle is just about what I want. Now I've focused on just the central portion of this tank. I'll have to go back and do additional work on the nose and the tail of this particular piece. And to do that, I'm actually going to have to pull some of this curl out. You'll see why that's important momentarily, but let me just do that next. And I'm going to switch to a wheel with just a bit more contour. And now we'll wheel the front portion of this. The reason I had to flatten this part out is because if I didn't, the tail end of it would be colliding with the base of the machine. But we can uncurl it and do the smoothing, and then once it's smooth, we can curl it right back where it came from. And that'll do a nice job. So I've wheeled sort of 45 degrees from one edge. I'll rotate the part and wheel in the opposite direction now. So our tracks are crossing each other. And I think you can see how quickly the part is being smoothed by the wheel. Again, my goal is to have my tracks just about evenly spaced. They're just about touching. And then I'll do a little wheeling straight across the part. Pretty light pressure between these wheels. We're doing more smoothing with the wheel than we are actual stretching. Okay, now we'll have to correct the curvature on the nose of this so we can test its fit against the tank. Okay, the shape is coming along nicely. I need to do some smoothing on the rear of the tank. And again, to do that, I'll have to take out some of the curl on the rear. By crossing my tracking pattern, it really helps me to smooth the lumpy part out. Okay, now we'll have to recurl this part to make it match. Okay, we're pretty close to having a good fit on this part. The next step is curling over the edge of the tank top where it meets the side. And I'll be working over a post dolly with a slap hammer to do this. I'll put my earmuffs on. And the way this is done is that the metal is put on top of the post dolly and it's overhanging about 1/2 inch. And now we'll tap it down against the post dolly with the slap hammer. And you can see that puts a nice curl on the metal. So you can see that working carefully with a slap hammer and post dolly, you really can put a nice rolled edge on the panel. If you're doing very much of this, however, there really is a faster way. I've made a special set of dies that I call rounding over dies for the beading machine. And they do the same function, but I think you'll see that this is both faster and smoother. So we'll start the metal through the rolling over dies. The bottom die has a stop on its edge, And I make sure that as I roll the metal through the machine, I keep the edge of the metal tight against that stop on the lower die. That way I'm sure that the rolled over edge is very consistent. So there's the first edge completely rolled over. We'll do that to the second edge, and then we'll be ready to join the tank top to the two halves. We're getting ready to weld these parts together now. I'm going to use the oxyacetylene welding process to make the actual weld bead. Right now we're simply doing the tack welding, and I'm going to use the TIG machine for tacking because it's a lot more convenient. So I've cleaned both edges with Scotch-Brite just to make sure that there's no contaminants on the edge. And we're going to hold this part into place. It helps a lot to put a little strip of metal across the front of the tank, and that just keeps the front part from falling as I'm aligning the witness marks on the rear. So I'll put my hood on and we'll get ready to make the first tack weld. We'll get the metal aligned, and I'm looking for a point where there's absolutely no gap between the metal. That's where our first tack weld will go. This is a fusion weld. That is a weld that's made by not adding any filler rod. And the reason I'm not adding filler is because I'm using my left hand to align the parts, so I don't have the freedom to hold filler rod as well. We'll get the metal aligned for the next tack. And we'll continue in this process toward the front of the tank, tacking as we go. So I've made tack welds spaced no more than 1 inch apart along this whole seam. And what's next is I want to align the metal at the seam with the hammer and dolly in preparation for the welding process. So I'll be using a dolly on the inside, and I'll be hammering on the outside. And my goal here is just to get the metal absolutely flush at the weld joint. Okay, so now that we're certain that the metal is at the same level at the joint, we're ready to come in with the oxyacetylene torch and complete this weld. This process has some real advantages. One advantage is that the equipment cost is low. Quite a few home shops do have an oxyacetylene welding outfit. Not many have a TIG welding outfit. Another advantage is that the weld you get from oxyacetylene welding is very soft, and this has some great advantages. One is that it's easier to hammer the weld flat after it's in place. Another advantage is that the soft weld is less prone to cracking than a TIG weld, which tends to be harder. So it takes a few special things to make an oxyacetylene weld. You need to use a special flux. This is aluminum welding flux, and it comes as a powder which you mix with water to make a light paste. And then that paste is brushed onto the joint, both on the inside and out. And it takes a special welding lens. This flux gives off a very bright yellow glare when heated, and you can't see through that glare unless you have a special lens. The lens I'm using is made by TM Technologies. It's called the TM2000 lens. It's really the only game in town for gas welding aluminum. I should mention that the flux is somewhat toxic, so be very careful not to get it on your skin, and especially careful not to ingest the flux. Also, the fumes given off by the flux are harmful, so you should work in a well-ventilated area. And especially try and weld so that you're not directly above the puddle, because the heat can carry the fumes from the flux up into your nose. The welding rod I'm going to use is 1/16 diameter, 1100 alloy rod, which is pure aluminum rod. And I'm using a single-aught welding tip. Okay, I think we're just about ready to start our weld. Now, when you're gas welding aluminum, it's very important that you do not start the weld right at the end of the joint. The proper procedure is to start the weld about 1 inch away from the end and then weld to the end. Once that's done, you can start at the beginning of the first weld and weld all the way to the other side. You'll find that this will go a long way toward preventing cracking of the weld. So we'll light the torch. Use a neutral flame, medium-sized flame. And we'll start our weld, like I say, about 1 inch away from the end. Weld up to the end, then we'll stop. We're just waiting for a puddle to form. There's our puddle. Dip the rod in and weld to the end. Okay, now that the end is sort of captured with our first weld, we can now start welding toward the other end of the joint. When welding aluminum, you lay the torch down a little flatter than you would for welding steel. And it's a good idea to move pretty rapidly. Rather than use a small flame and move slowly, it's really better to use a large flame and move along at a pretty good clip. You tend to get a better weld that way. Okay, so here's our finished weld. You can see it's come out to be fairly uniform. And the next step is I'm going to use a hammer and dolly to hammer this weld down flat. And you'll see that it will go absolutely flush, both inside and outside. And I'll be using a lightweight hammer for this with a relatively low crown face and my favorite dolly, an egg dolly. And I'll place the dolly under the metal, press up really hard, and then hammer on the weld until it flattens out. So you can see that this hammering really does a nice job of flattening out the weld on the inside and outside, and it also puts more strength into the weld. We're work hardening the metal in the weld area, which gives it more strength. And you can certainly do an entire gas tank seam with a hammer and dolly. It's a lot of work, so I'm going to show you a tool that kind of speeds this process. This is a pneumatic planishing hammer. This works exactly the same as a handheld hammer and dolly, but it's a great deal faster. And I'll use this tool to flatten out the rest of the weld. So I think you can see how much this speeds the process using the planishing hammer. So what's next is I need to do a little hand work on this part to blend the shapes together. I flattened the weld very nicely, but at the expense of losing a little bit of the continuity of contour. Okay, that looks pretty good. So by using the slap hammer and the egg dolly, I've been able to smooth out this area that was flattened partially by the planishing hammer. So if you look closely at this, you can see that the weld is absolutely flush with the metal around it. That's true both inside and out. I'll show you the inside in just a moment. So here you can see how nicely the weld is flattened out on the inside as well. So at this point we have all three parts of the tank welded together, and I've done hammer and dolly work on all the joints, so all of the forms blend together into a continuous shape. And if you're planning to use filler on the tank, this is probably as smooth as you need to get it. I'm going to take this one step further. I'm going to go through the metal finishing process, which gets the metal smooth enough that it can be painted with no filler, or it could actually be polished if we chose to do that. I've made a fixture that allows me to rotate the part and hold it firmly in place while I work on it. So I'm going to lock this into position. And the first step of metal finishing is to run lightly over the surface with the file. What this does is to clearly show us where any low spots are. So the file only touches the high spots. Anything left unfiled we know is a little bit below grade. So the next step is to start working up the low spots, and I'll be doing that with this bullseye pick. It's an ingenious device. When you squeeze the handle, the tip of it comes up right into the center of this sort of gun sight affair. So we put the gun sight over any low spot we want to raise, squeeze the handle, and that very nicely brings up the low spots. And then we'll draw the file over it again. This time the low spots are about half the size they were previously. We'll bump them up again. And file again. And there's just a hint of the low spots left in this area. We'll tap those up. And file again. Okay. So this one area is pretty fully smoothed. We'll continue the metal finishing process across the whole surface of the tank. So we've completely metal finished the tank now, and I think you can see that it's very smooth. All the contours are very continuous. And we're ready now to make a pattern for the bottom of the tank. So I'll be using a thinner material for this pattern. This is just butcher paper, and I've cut a piece roughly to size. I'm going to use masking tape to help position the part on the tank. Okay, so it's pretty well positioned now. And now I'm going to use what I call the dirty finger technique to find the edges of the tank. And that's why we're using butcher paper, because it's soft and flexible, and I can easily make an imprint in the paper just by rubbing my thumb across it. Okay, so that's defined the edges of our pattern. Now we can take the pattern off the tank. And we'll trim on this edge. Then we can fold our pattern in half and test how symmetrical our tank bottom will be. So here's the part we cut from the pattern. This is the same material we've used for the rest of the tank, 80 thousandths thickness, 3003 H14 aluminum. And I've softened it so it's no longer H14. I've annealed this part to make it easy to form. So we brought it down to the dead soft condition. And the next step is to contour the part to match the tank. The first shape I'll go after is this large radius concave portion. And I can just push this against my body to start getting that shape into it. Tweak it just a little more with my hands. And that's looking pretty good. The next step is I'll put a curl on the tail end of the tank. And I'll do that by working over the post dolly using the slap hammer. We'll go down just a little bit and then try it back on the tank. Looks like I need a little bit more curl. Try it back on the tank again. That's looking pretty good. So now all the curving we need is from this point forward. And to aid that process, I'm going to take the post dolly out of the vise so I can use the vise to hold the piece. And this should give us nice support for curling the front. Okay, we'll try it back on the tank. So far, so good. Back to the vise. A little more curl in this area. Back to the tank. So we're zeroing in on the shape that we need. Okay, so far so good. So we've established the all-over shape of this part. Before I really can get a good fit in here, there's one more step I need to do. The front of this tank, as I've bent it, is straight across, and we know that to match the tank itself, it needs some doming. So I'm going to work with the mallet and sandbag to put the dome in this part, and then we'll smooth that out. Okay, we'll try this back on the tank. I'm going to bulge it a little more in this area. We'll try it again. Okay, just a little bit more doming in the bottom. We'll try that in place again. correct the shape a little bit. Okay, I realize there's a gap in here. I can fix that. My next step is to smooth this area that's been worked against the sandbag, and I'll use the English wheel for that. Okay, I think we're ready to try this back on the tank. See how our fit is coming. I actually think we have a pretty nice transition between these two shapes now. The next step is to roll it through the rotary machine to curl the edges over. You can do the same work with a hammer and dolly. The only advantage of the rotary machine is it's both faster and you tend to get a more consistent radius working this way. So one side is done. One other thing I forgot to mention is that when I made this part, I intentionally added about a ½ inch to both the front and the back of my pattern. Because this part is stepped up a small amount from the radius that we just put on the edge, the circumference of this part will be a little bit larger than the circumference of the pattern we made it from. So that's why I allowed the extra material. And what's next is we'll scribe this and trim it so it's a perfect fit. And then we can tack weld it into place. Before we can put the bottom of the tank, we have to make the hole for the filler bung and get that welded into place. So I'll use a hole saw now to make that opening. Put a little bit of cutting fluid on the teeth of the hole saw and a little on the metal to be cut. And there's our hole. Okay, I've gone ahead and welded the bung in the top of the tank, and I've gone ahead and fitted carefully the bottom of the tank to match the shape of the top, and it's tack welded into place at this point. I want you to look closely at how continuous the contours are of the bottom flowing into the sides and the top. This is very important because we can't get inside this part with a hammer or dolly to straighten it. So before it's welded, you have to be sure your fit up is just as good as you can get it. And because there's so much contour on the edges to be welded, they're not going to distort very much with the welding process. So I'm going to TIG weld this bottom seam. I want to demonstrate that both oxyacetylene and TIG welding are good processes to use. And after the weld is in place, we'll sand the weld down and we'll be ready to fit the tunnel into the tank. So here's the finished weld, ready for sanding. We'll use a small sander to knock the top off this weld to make it flush with the metal around it, and then we can file it smooth. I'm going to use a little bit of soap as a lubricant for the sandpaper. Okay, I think we're just about finished filing the weld area smooth. If you find any high spots as you're doing this finish work, you can tap them down with a hammer. On highly crowned shapes like this, you can usually lower a high spot without any problem. If you find low spots, that's a little more difficult to deal with. We simply don't have any way to get inside to raise a low spot. Nevertheless, I think we've shaped the bottom of the tank pretty nicely. The next thing I'll do is to lay out the opening where we will put the petcock, and I'll use a 1-inch hole saw to create the hole for that. We're going to fit the tunnel into the tank next. I've had this tunnel made out of especially thick aluminum. This is 1/8-inch thick aluminum. I've had it formed on a press brake with a radius die. And there's a very good reason why I choose to use metal this thick for the tunnel. Aluminum tanks are famous for cracking, and most often they crack at the area where a heavy mount is welded onto the thin skin of the tank. So my strategy is that by putting a very heavy tunnel in a tank, this becomes a backbone, essentially, that we can weld tabs onto, and that should make a very strong tank that should live a long time. So this tunnel is 2 1/4 inches thick, or 2 1/4 inches wide. I've made 2 marks on my tank, 2 1/4 inches wide. We can trim the tank on these marks to fit the tunnel into place. Remember when we started the tank project, we made a pattern that had a reference line in it, showing where the top surface of the top tomb of the chassis rests in the tank. This is our reference for knowing how deep the tunnel is cut into the tank, both front and rear. A convenient way to remove the material for the tunnel is to drill a pilot hole first, and then cut a strip of metal out using your left and right aircraft shears. This is a roughing cut, so I'm leaving about a 1/4 inch material right on the line for our finished cut. But this is a good way to get rid of the waste. The tunnel is put into the tank now, and we need to mark it for trimming. So I'll use a felt tip marker and simply trace around the edge. And this will give us the line to trim on. Eighth-inch material is too thick to cut with hand shears, so I'm going to use a bandsaw to do the cutting. If you don't have a bandsaw, a saber saw would work as well. Okay, so I've used the TIG welding machine to join the tunnel to the tank. Unfortunately, you can only use a TIG for this process because we're joining 1/8-inch material to 80 thousandths material. That's just not possible with an oxyacetylene torch. So we'll go ahead and weld in the threaded bung for the petcock. We'll sand this weld to make it smooth, and we'll have ourselves a gas tank. The fabrication is finished on our tank at this point. If we were going to weld on tabs for mounting, that would be the next step. Certainly rubber mounting a tank like this is a better way to go because the cushioning of the rubber mounts goes a long way toward preventing cracking from happening. Once all the welding is completed on your tank, it's very important that you check it with pressure for leaks. And when doing this, you must be sure to not use more than 2 or 3 psi, otherwise you can balloon out the tank. So we'll connect the air line to the tank. I've put a fitting in the location where the petcock would go. And we'll start dusting over, brushing over the seams with a soapy water solution. And should we have a leak, what you would see would be a lot of little bubbles forming. Actually, I did find a little leak here. Let's continue, see if there are more leaks. Go all around the seams on the side. Test the front seam. Okay. Flip the tank right side up. I can hear a little leak around the cap. I think that's just the seal on the cap. Test the top seam. Okay. Dennis, can you zoom in real close? Get a look at this leak right here so everybody can see what a leak looks like. We'll have to re-weld that area. Let's take a look now at the tank I made for Darren Rock's bike named Twisted. This is by far the most complicated tank I've ever made. The two things that made it difficult were the unusual shape and the rubber mounting system that is completely hidden. You can see the tail end of the tank twists off to one side and really gives it quite a wonderful look. It has a deep tunnel going down the center, and the mounts are incorporated into the tunnel. There are saddles welded into the tunnel near the front, and these saddles have pockets in them that engage rubber biscuits attached to the frame. The rear is mounted with a bolt going through a rubber grommet, so the entire tank is completely rubber mounted. And this resilient rubber mounting isolates the tank from vibration, and that's what keeps the mounts from cracking. Now we'll place the tank back on the bike. Let's take a close look at the elements of the rubber mounting system. The rear mount is based on a threaded boss that's welded into the frame, and there's a 3/8" bolt that goes into the boss, and the bolt has a washer under its head that fits against a rubber grommet. Moving up the frame, you'll see there are two strips of foam tape that bond to the backbone of the frame. This tape is a very important part of the mounting system. The tape is 1/4 inch thick and 1/2 inch wide, and it completely fills the space between the tunnel and the frame, so the tank is really resting on a cushion of foam, and the foam supports most of the weight. You buy the tape with an adhesive backing. You simply peel the paper strip off the back, and then it can be bonded into place. It's important that you use a closed cell foam tape so it can't absorb liquids like water or gasoline. And near the front of the tank there are 4 rubber biscuits that are a snug fit into the tunnel. I found these in a hardware store. They're designed as caps for chair legs. They slip over sleeves that are bolted onto the frame. Let's pull these sleeves off and take a closer look. These are the rubber chair leg caps, and they simply fit over pieces of 3/4 inch round steel bar stock. One of the pieces I've threaded, and the other I've counterbored for a 5/16 bolt, so the bolt head fits flush. It screws into the other part, and the rubber caps just slip on. Very simple, but very effective. The rear mount is based on a rubber grommet, and the grommet fits into a hole I've made in an extension of the tank tunnel, and I've used a 3/8 inch flathead bolt with a washer under its head to go through the grommet into the threaded boss in the chassis. It provides a very resilient mount. And I'll show you how the rubber caps fit into the sockets in the tank tunnel. It's a nice snug fit, and these cushion the tank but hold it tightly against the top frame tube. It takes a little development of hand skills to be able to make metal as smooth as this. But if you're willing to use a little bit of filler, then the metalworking doesn't have to be done to this degree of perfection. The biggest caution when making a gas tank is your welds have to be really, really good. If you're not confident in your welding ability and you're not certain that you can get welds with full penetration, you really might consider having someone else do the welding on your gas tank. So thank you folks, and we'll see you next time. This is Ron Covell signing off.